Hello everyone, welcome to Praveen Tutorial Point. In this session, we are going to discuss about the Newton's law of gravitation. This Newton's law of gravitation was given by Newton, and in this Newton's law of gravitation, he says that the force of attraction between two masses. See, in this universe, any two masses exert some force. Mass exert some force on another mass. So in the same way, the two bodies will exert force on each other. So let us see that. So here is a mass m1 and here is another mass m2. This is the center of the mass and this is the center of the mass, and these two masses are separated by a distance r. So the force of attraction between these two masses, is directly proportional to the product of their masses, and this force is inversely proportional to the square of the distance between them. See, this mass will exert some force on this mass, and this mass also will exert the equal force on this mass. The force exerted by this mass is force of mass 1 on mass 2. So force F12. In the same way, this mass also will exert some force, that is force of second mass due to first mass, F21. So these two masses exert equal and opposite force. Both forces are equal, but they are in opposite direction. And here, by these two, and they are separated by a distance r. Here to here the distance is r, m1 to m2, and m2 to m1, again r. So r square. And by these two we can write it as F is directly proportional to m1 m2 by r square. And to make this equal, we have to bring a constant. That constant is capital G. So capital G m1 m2 by r square, and this capital G is called universal gravitational constant. Universal gravitational constant. And here G equal to F r square by m1 m2. F r square by m1 m2. And this capital G is having a value that is 6.67 into 10 to the power of minus 11. And coming to the unit, see, this is the value of G. I mean, formula for G. G equal to F r square by m1 m2. So F in the sense force, Newton, r square distance, meter square, by masses, so kg square. So capital G equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So now let us try to give some definition for this Newton's law of gravitation. What he defined. So here there are two masses. So there is a force between the two masses. See, in the universe, force of attraction between any two masses is proportional to product of the masses. Here we have seen that F is directly proportional to m1 m2. Product of their masses, and inversely proportional to square of distance between the masses. Square of distance between the masses. See, directly proportional to product of the masses and inversely proportional to the distance between the masses. If the masses increases, the force between the masses also will increase. Sorry. If the masses decrease, the force between the masses also will decrease. And if the distance between the masses increase, force will decrease. If the distance between the masses decrease, force will increase. And as this force is a vector quantity, it has a magnitude and it has a direction also. So what is the direction here? The direction is along the line joining the two masses. That is the direction. That means this will exert a force. M1 will exert some force in this direction and M2 will exert some force in this direction. So the direction will be along this line. The force of attraction between the two masses will be along this line. And here, now, if you consider some points about this Newton's law of gravitation, coming to the first one, that is central force. Newton's law of gravitation is a central force. See, it will act along the line. Along the line, the force will act. It won't act in this way. It won't act in this way. It will act along the line. So, it is central force. From the center of the masses, the force will act. In the same way, the force is attractive in nature. The force of this gravitation is attractive in nature. Any two bodies will have attraction between them. See, if you consider charges, positive charge and positive charge will repel, and positive and negative charge will attract. But coming to this one, any two masses will attract. So, the force is only attractive force. And force is independent of medium. The force will not depend on medium. Wherever the masses are, whether the masses are in vacuum or whether the masses are in water or in air, wherever it may be, the forces are independent of medium. Any medium, the force will remain same. And next, the force on due to first mass will be equal to the force acting on the second mass. That means both will apply equal and opposite forces on each other. But y minus means the both forces will be in opposite direction. See, the earth will exert some force on moon. In the same way, moon also will exert the same force on earth. Or if you take this pen, earth will exert some force on this pen. This pen also will exert some force, same force on the earth. But due to that the mass is so big, it will attract towards it. It also will apply some force, but it is negligible. In the same way, valid for point masses. This Newton's law of gravitation is valid for only point masses. But we'll consider for planets, stars and everything. See, these are all big, very huge masses. But why this point valid for only point masses? That means, see, the distance between the planet and planet or a star and a planet is too big. So from this mass or a planet, the appearing star will be a point mass, or the appearing planet or a satellite will be a point mass. So this is valid. This is valid only for point masses. That means if the distance is too long, then only this is valid. And one more thing is, law of gravitation is with long range, and this is a weak force. Gravitational force is having a long range with weak force. Long range. Here we have to consider the distance between the masses. Distance between the masses is too long, so range is so big, and force is weak force.